Here's integrated 3. It's problem 12-30. It says, what is the sum of each infinite series, if possible? So I know that there's this formula, and it's a over 1 minus r, but I was wondering, like, how can you guys find your formulas? So I just looked in the back of the book. Usually if I didn't know it already, I would just Google it, but you can look up infinite. Well, it's right here. So infinite geometric series, and it'll give it to you. It's S equals, you can look on page 538 if you don't understand it, but it's the sum is A over 1 minus R. I already know the formula that A is the first term and R is going to be the multiplier. So I'm just going to use that formula for these. You can't get a sum of an infinite series unless R is less than 1. Or, well, if it's like in between 0 and 1, it has to be a fraction because it has to be getting smaller and smaller. In this one, I see that R is, it's multiplying by a half each time. So R is a half. So I'm just going to plug in A, which is the first term, over 1 minus R. So that's 6 over 1 minus a half is a half. And I know that when I'm dividing, if it's 6 divided by a half, that's 6 times the reciprocal of a half. So I'm getting 12. Let's see if that's right. That's right. And then this one is just written in summation notation, but this tells me that it's infinite series and that it's multiplying by 1/3 each time. It's taking each term and multiplying it by a third. So so I need A over 1 minus R. So the first term would be when I plug in a 1. So 1/3 times 1 is 1/3, so that's A. And then 1 minus R, well, R is a third. So then I just did fraction math. I got a common denominator down here, 3/3. 1/3, or 3/3 minus 1/3 is 2/3. So now I have 1/3 divided by 2/3. But when I divide, what I really do is flip and multiply. So 1/3 times the reciprocal of 2/3, and then I cancel out and I get a half.